Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the strangest and most slippery questions in all of science. Can the universe exist without time? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. So, time. It seems so ordinary, doesn't it? You check the clock when your tea is steeping, or glance at your phone to see how many minutes until the bus arrives. You feel it in the rhythm of your heartbeat, in the rise and fall of the sun, in the way bread cools on the counter after it comes out of the oven. Time is the background music of our lives, the quiet pulse against which everything else seems to move. Yet if you ask a physicist or a philosopher, they might hesitate before answering what time really is. They might even tell you something unsettling, that perhaps at the deepest level of reality, time isn't there at all. This is where our exploration begins, not with certainty, but with a question. If the universe could exist without time, what does that mean for us? The tiny creatures who measure out days with calendars and birthdays, who worry about deadlines and who remember childhood as though it were a distant land. What if this flow we feel so deeply is less like a river and more like a story we've been telling ourselves? Take a moment to notice your own surroundings. Maybe you hear the faint hum of an appliance or the sound of a car outside your window. Maybe you notice your own breathing, slow and steady, or the gentle ticking of a clock. These are signals of time's presence in your life, anchors that reassure you that there is a now unfolding moment after moment. But here's the strange thought. What if this experience of flow is only local, only ours, and not something the universe itself recognizes? Einstein once remarked that the distinction between past, present and future is only a stubbornly persistent illusion. To him, time was not the universal stage upon which the universe acted, but a flexible, shifting part of the stage itself. The way you and I experience seconds ticking forward is not how a satellite circling above experiences them, nor how someone standing at the edge of a black hole would. Already, time begins to look less like the steady march of a metronome and more like a pliable, elastic fabric. Yet our intuition clings to flow. You feel yesterday slip away. You sense tomorrow approaching. You measure, record, and remember. That's how our brains have been wired, how societies have been organised. If a clock were to stop, it would feel as if the world had stumbled. But if time itself is not fundamental, then clocks are only telling us a story. One stitched together from rhythms of change, from the rising entropy of the cosmos, from the ways our minds hold on to what has happened and anticipate what is to come. Imagine for a moment that you are sitting by a river. The water moves steadily past, always flowing in one direction. You can dip your hand in, you can watch leaves drift by, you can even count the ripples. This is how time feels to us, something steady, directional, unavoidable. But now imagine lifting your perspective higher, higher still, until you can see not only the river but the mountains where it begins, the valley where it flows, and the sea where it ends. From this vantage, the river is not flowing. It is simply there all at once, its path spread across the landscape. Time, some scientists suggest, may be like that. Not a moving current, but a whole terrain in which past, present and future coexist. This idea can be disorienting, especially when you try to place yourself within it. Are you a traveller moving from one point to another, or are you already present at all points, simply unaware of it. The block universe, as it is sometimes called, suggests that all events, your birth, this moment listening, and your far future are equally real, like pages already written in a book. The sense of turning from one page to the next may be our perception, not the universe's. Of course, this view is not the only one. Some philosophers insist that only the present is real, that the past has slipped into non-existence and the future has not yet arrived. This tension between our intuition and the strange claims of physics is where our journey will linger. We'll move gently between the ordinary anchors of daily life, cups of tea, the rhythm of sleep, the orbit of the satellite, and the vast abstractions of relativity and quantum theory. As we set out, remember, you don't need to resolve this question tonight. You don't need to hold all the equations in your head, or even agree with Einstein or anyone else. Tonight is about wandering softly through the landscape of ideas, letting them wash over you like waves on a shore. If your thoughts slip away and you find yourself drifting into sleep, that is perfectly fine. After all, sleep is itself a kind of doorway where time bends and blurs, where minutes stretch or vanish in an instant. You'll wake to a new day, and time will feel as ordinary as ever. But perhaps, just perhaps, a quiet part of you will carry the question, is time as real as it seems, or is it only the music our minds are playing? And so we begin, not with answers, but with curiosity, with a willingness to set down our clocks for a little while and listen to the silence beneath them. If we've opened the door by asking whether time is as real as it feels, the next step is to notice how differently it appears depending on where you stand. For most of daily life, time feels like the simplest thing in the world. You wake up, you brush your teeth, you glance at the clock and you move through the day with a steady rhythm. Breakfast leads to lunch, and lunch leads to dinner. One task follows another, one conversation slips into the next. It feels like beads sliding along a string, ordered, predictable, and utterly unshakable. This sense of flow is so deeply ingrained that it can feel absurd to question it. Of course time passes. How else would you explain the way bread cools after it comes out of the oven, or the way shadows stretch across the sidewalk as the sun lowers? Yet science, when it peers closely, whispers something different. The universe, it seems, does not carry a single metronome in its depths, ticking in unison for all. There is no grand master clock that dictates the rhythm of stars and people, of black holes and boiling kettles, all marching to the same beat. Instead, what appears so steady in daily life is revealed to be more flexible, more negotiable, depending on where and how you observe it. This was not always how humans thought. For centuries, the assumption was that time flowed like a universal river, the same for everyone, everywhere. Newton himself described absolute time as something that existed independently, flowing uniformly, unaffected by anything else. In Newton's view, whether you were on Earth, on the Moon, or floating in the void, a second was a second, and a minute was a minute, the same everywhere. This picture made intuitive sense, and it matched the mechanical clocks people were beginning to trust in their cities and homes. But intuition, as comforting as it is, sometimes hides deeper truths. Imagine you are waiting in line at a cafe. The minutes stretch, each one feeling longer than the last as you shuffle forward. Then, when you finally sit down with a friend and fall into an engaging conversation, an hour seems to vanish almost instantly. Already, your own body and mind reveal that time is not as uniform as you think. Psychological time, the way your brain feels its passage, is elastic. Scientists measure this elasticity in countless experiments, noting how stress, joy, or boredom can expand or contract our sense of duration. But physics goes further still. It tells us that even the objective ticking of clocks can disagree. Einstein's theory of relativity gently shattered Newton's universal clock. He showed that time is woven into the fabric of space itself, and that fabric can stretch, bend, and ripple. Two clocks, identical in design, will tick at different rates if one moves quickly or if one sits in a stronger gravitational field. This is not a trick of perception. It is measurable, real, and confirmed by countless experiments. Satellites orbiting the Earth carry clocks that drift away from those on the ground unless adjusted. Without accounting for relativity, the GPS in your phone would accumulate errors, sending you kilometers off course in a single day. So here we find ourselves in an odd position. Intuition tells us that time flows steadily, like a current. Physics tells us that time bends and stretches depending on context, which is true, perhaps both, but only within their domains. For your morning routine, Newton's picture is more than enough. You don't need relativity to boil an egg. But as soon as you reach out to the stars, as soon as you rely on satellites or consider the edge of a black hole, Einstein's view becomes unavoidable. This mismatch between intuition and science can feel unsettling. You might wonder if even time itself is not steady. What can be trusted? Yet there is also a kind of beauty here. It shows that the universe is richer than our first impressions. Our senses, evolved for survival on a small planet, grasp one layer of reality. Science, through mathematics and experiment, opens another. Both are true in their own ways, the truth of lived experience and the truth of cosmic geometry. Perhaps the best way to hold these together is with a metaphor. Think of music. To your ear, a song flows forward, each note following the last in rhythm. That flow feels real, and it is how you experience the piece, but written on the sheet, the notes all exist together, simultaneously present. The flow is in the playing, not in the ink. Likewise, intuition gives us the melody of time, while physics lays out the score. Neither is false. Both are perspectives on the same reality. This is the gentle tension we'll carry forward. Time, as you live it, feels like the most natural thing in the world. Time, as science sees it, bends under speed and gravity, loses its uniformity, and becomes a feature of space-time itself. In the chapters to come, we'll step deeper into Einstein's vision, exploring how elastic time reshapes not only clocks and satellites, but our very sense of what now means. For the moment, though, it's enough to rest in this thought. The simple flow you feel every day is a story told by your mind, anchored in rhythms and cycles. The universe, quiet and vast, may be keeping a very different kind of time. When we step into the early 20th century, we find physics standing on the edge of a quiet upheaval. For more than 2 centuries, Newton's picture of time and space had reigned without serious challenge. It had allowed sailors to chart courses across oceans, astronomers to predict eclipses, engineers to build bridges and machines. The laws of motion and gravity were so dependable that many believed the universe was simply a grand clockwork, precise and eternal, with time flowing in the background as steady as the tick of a pendulum. Yet, into this world of certainty walked a man with unruly hair and a way of seeing that bent the familiar rules until they gave way to something astonishing. Albert Einstein did not begin with laboratories or great observatories. He began with thought experiments, small acts of imagination, carried out in quiet rooms and on long walks. Einstein often asked himself what it would be like to chase a beam of light. Could you ever catch it, ride alongside it, see it standing still? Newton's universe would have said yes, in principle. Speed was like a number you could add or subtract. If you ran after a wagon and the wagon was moving at 10 miles an hour and you were running at 5, the wagon would pull away from you at only 5. So why not apply the same idea to light? But experiments at the end of the 19th century had shown something stranger. Light, no matter how you moved, always sped past you at the same velocity, unyielding, untouchable, as though it carried its own private law. Einstein took this not as a puzzle to be corrected, but as a truth to be embraced. And from that embrace came the special theory of relativity in 1905. relativity declared that space and time were not separate backdrops, but parts of a single fabric. If the speed of light was unchanging, then it was space and time themselves that must shift and stretch to keep the law consistent. This meant that events that seemed simultaneous to you might not seem simultaneous to someone else moving quickly. The ticking of a clock depended not only on its gears, but on the motion of the person watching it. What had felt absolute became relative, and the notion of a universal now was quietly dissolved. Imagine two friends standing at a train station. One waits on the platform while the other rides away at high speed. To the traveller, the seconds on their watch pass normally. To the friend left behind, those same seconds are stretched. If they later compare notes, they discover that less time has passed for the traveller than for the one who waited. This is not imagination. It has been measured with precision, using jets and atomic clocks. Even your GPS depends on this truth. The satellites circling high above the Earth tick at slightly different rates than clocks on the ground. Engineers must account for these shifts, or else your navigation would quickly drift into nonsense, placing you kilometers away from your destination. At first, the idea that time could dilate, that it could move at different speeds for different observers, seems almost absurd. But then you realize that it has to be this way for the laws of physics to stay consistent. If light is always the same speed, then the price we pay is flexibility in time and space. And rather than breaking the universe, this discovery stitched it together into a more coherent whole. Time was no longer a passive river, but an active participant in the dynamics of reality. But Einstein was not done. A decade later, in 1915, he turned his gaze to gravity, the silent architect of the cosmos. Where Newton had described gravity as a force, pulling at a distance, Einstein saw something subtler. He imagined space-time as a kind of fabric, flexible and dynamic. Massive objects like stars and planets create curves and dimples in this fabric, and other objects follow those curves, like marbles rolling across a stretched sheet. In this view, gravity is not a mysterious tug. It is simply the shape of space-time guiding motion. And with that shift, time itself became tied to gravity. A clock placed closer to a massive object will tick more slowly than one farther away. Your feet experience time ever so slightly differently from your head, because your feet are closer to Earth's centre of mass. The effect is minuscule in daily life, but across galaxies and black holes it becomes profound. Pause for a moment and let that thought rest with you. Even as you lie still, time is not uniform throughout your body. The passage of seconds is a little quicker above you than below. You don't notice, of course. Your senses are not tuned to such fine distinctions. But physics is, and with delicate instruments, it can measure this truth. It is as if your very body contains its own tiny version of relativity, a reminder that the flow of time is not a single current, but a mosaic of currents, each shaped by gravity and motion. Einstein's revolution was not loud. It did not arrive with fanfare, but with equations and metaphors, with thought experiments and quiet persistence. Yet it changed everything. It told us that there is no absolute time, no universal now, no single clock that the cosmos consults. Time is elastic, woven together with space, stretched by motion, slowed by gravity. And once you have seen it this way, you cannot return to the simple certainty of Newton's clockwork. Still, relativity does not erase our everyday experience. When you wait for bread to bake, when you drift into sleep, when you walk to meet a friend, time feels steady, trustworthy. It is only when we reach toward the cosmic scale, or measure with the finest instruments, that the hidden pliability emerges. The beauty of Einstein's work is that it allows both views to coexist. For the human heart, time flows. For the universe, time bends. And it is in that quiet tension that we begin to glimpse a truth stranger, and perhaps more beautiful, than either view alone. If you've ever laid down on a hammock and watched the fabric sag beneath your weight, You already hold in your body a picture of Einstein's second great insight. Before him, gravity was thought to be an invisible tug, something that objects exerted on each other across empty space, instant and unmediated. Newton's laws describe this force perfectly well for apples falling, moons orbiting, and cannonballs arcing across the sky. Yet even Newton admitted he didn't know what gravity was, only how it behaved. It was Einstein who replaced the mysterious pull with something quieter, more geometric, and in a way, more elegant. He imagined that space-time itself is not rigid but flexible. Place a massive object, a star, a planet, even your own body, onto this fabric, and it bends. Smaller objects move along those curves, not because they are being yanked, but because they are following the straightest possible path through a warped landscape. This is the essence of general relativity, and it changes not only how we think about falling apples, but how we understand the universe itself. To picture this, imagine rolling a marble across a trampoline. If no one is standing on it, the marble travels in a straight line. But if someone climbs into the centre, the fabric sags, and the marble's path bends toward the dip. It may even circle around in an orbit. This is how Earth keeps circling the Sun, not pulled by an invisible hand, but guided by the curve of space-time created by the Sun's mass. The elegance of this picture is that it requires no mysterious force at a distance. Everything simply moves along the terrain of space-time. Yet this terrain is not only about space, it is equally about time. Gravity does not simply bend paths, it slows clocks. If you were to take two identical watches, one placed at the bottom of a mountain and the other at the top, they would not tick at the same rate. The watch closer to Earth's mass would tick more slowly. The effect is tiny in our daily lives, but it grows larger near extremely massive objects. Astronauts aboard the International Space Station, though they live in microgravity, are still in a gravitational field strong enough to alter the passage of time, and satellites, high above Earth, tick differently still. Engineers designing GPS systems must account for this, or else your phone would lead you astray, drifting your location by kilometers each day. What makes this remarkable is not simply that it happens, but that it happens in silence. Gravity does not shout. It does not tug at you in a way you can sense directly. You feel its effect as weight, as the firmness of the floor beneath your feet, as the heaviness of your body sinking into the mattress at night. But the deeper truth is invisible. The flow of time itself is being adjusted moment by the presence of Earth beneath you. Consider how strange this is. You live your life trusting that 1 second here is the same as 1 second anywhere else. But it is not so. A clock on the surface of the Earth ticks differently from one on a satellite, and differently still from one placed near a black hole. Even your own body experiences this difference. Your head, slightly farther from Earth's centre, experiences time passing a little more quickly than your feet. It is an almost imperceptible imbalance, yet it is real, confirmed by experiments that can measure the tiniest discrepancies in atomic clocks. This is not science fiction. It is the daily functioning of the technology around you, the maps that guide you through a city, the airplanes that travel across continents, the signals that knit our world together. All of them depend on adjustments that account for Einstein's curved space-time. Without those corrections, our systems would collapse into error. In a quiet way, relativity has already been woven into the fabric of human life. The implications stretch far beyond Earth. Around massive stars, light itself bends, following the curves of space-time. Astronomers see distant galaxies magnified and distorted by the gravity of clusters in between, a phenomenon called gravitational lensing. Without ever touching, without any force pulling in the old Newtonian sense, gravity reshapes the very paths of photons. Time, too, slows in these immense fields, so that an observer far away sees events unfold at a crawl. For a star collapsing into a black hole, time near its surface appears to freeze to distant eyes, even though locally the collapse continues. What began as a thought experiment about geometry has become the foundation for our understanding of the cosmos. General relativity explains the orbits of planets, the dance of galaxies, the existence of black holes, and even the expansion of the universe itself. It shows us that time is not independent of space, but inseparable from it, both parts of a single entity that bends, stretches, and curves. There is something quietly humbling in this. You can feel gravity as a weight in your body, but you cannot feel the way it slows your seconds. You can look at the night sky and see stars shining, but you cannot see the invisible lens that bends their light. And yet these effects are real as the tick of your watch or the rise of the sun. They remind us that the universe is not obligated to align with our intuition. It follows its own deeper laws, and our role is to listen, to measure, and to imagine. As you sit here now, gravity is shaping not only your body's weight against the chair or the bed, but also the pace of your moments. It is quietly guiding every atom, every photon, every planet. And it does all this without words, without noise, without spectacle. A silent choreography that makes the universe coherent. In the sessions ahead, we will walk even closer to the extremes, where time stretches almost to breaking and space itself folds in on itself. But for now, rest with this image. You're living not in an empty void, but in a fabric, stretched and curved by every star and planet, by Earth beneath you, even by yourself. And in that fabric, time itself is not fixed, but elastic, shaped by the mass that surrounds you. If curved space-time is already strange, then black holes are where that strangeness grows so deep it begins to resemble poetry written in mathematics. A black hole is not simply a heavy star or a dark object. It is a place where gravity has gone so far that it has pulled space-time itself into a knot. The equations of general relativity, when pushed to their limits, describe a region where nothing, not even light, can escape. To most of us, they feel like science fiction, shadowy monsters haunting the edges of the cosmos. But to physicists, they are the purest, most extreme laboratories nature has ever built, places where time itself behaves in ways our intuition struggles to accept. Imagine falling toward a black hole. From your perspective, the journey might feel almost ordinary at first. You drift closer, pulled inward with increasing speed. Time for you seems normal, seconds ticking by as always. But if someone is watching from far away, their story of your fall is entirely different. To them, your approach slows. Each moment of your descent takes longer, stretched out, until you seem to hover at the edge forever. From their vantage, you never cross the threshold. You fade, dimming, time itself stretched so thin that you become almost frozen against the darkness. This boundary is called the event horizon, and it is one of the most profound stage settings in the universe. It marks the line between what can be seen and what is forever hidden. On our side, we still receive light, though redshifted, weakened, drawn out. On the other side, no signals escape. Space and time themselves have traded roles. Inside, the flow of time points inward, toward the singularity, making escape not only impossible in space, but forbidden in time. It is difficult to even speak of before and after in such a region. The geometry resists our language, and yet this is not merely theory scribbled on chalkboards. We've seen the outlines of these shadows. In 2019, the Event Horizon Telescope collaboration unveiled the first image of a black hole, M87 star, a giant sitting at the centre of a distant galaxy, its mass 6.5 billion times that of the Sun. What the world saw was not the hole itself, but the light bent around it, a glowing ring marking where space-time is distorted to the edge of comprehension. It was a moment when something once confined to imagination became a photograph, blurry but real, like a campfire glimpsed through fog. More recently, the same technique captured Sagittarius A star, the black hole at the centre of our own Milky Way, smaller but still immense, its presence confirming what astronomers had long suspected. Black holes also reveal themselves through sound, not sound in the air but ripples in space-time. When two black holes collide, they send out gravitational waves, tiny stretches and squeezes of the cosmic fabric, racing outward at the speed of light. In 2015, detectors on Earth caught these ripples for the first time, a faint shiver in laser beams that told of two giants spiralling together more than 1 billion light-years away. Physicists translated the data into sound, a chirp rising in pitch, the universe's own music of destruction and creation. Within that brief note was evidence not only of the collision, but of time itself being dragged and twisted on scales we could barely imagine. There is a kind of paradoxical beauty in all this. On one hand, black holes are regions of finality, places where time for an outside observer seems to halt. On the other hand, they are vibrant sources of discovery, teaching us how relativity operates at its edge. They tell us that time is not a universal constant, but a flexible participant in cosmic drama. For the astronaut falling in, time feels ordinary, unbroken. For the distant observer, that same journey is infinite, never quite finished. Both accounts are true, each framed by perspective, each revealing that time is not singular but relational. Think of it as watching rain on a window. From inside, the droplets slide down in smooth motion, one after another, continuous and clear. From outside, perhaps through a slow-motion camera, the same droplets seem to crawl, their path stretched, their descent delayed. Both stories describe the same water, yet the experience of motion depends on how it is seen. So it is with time near a black hole. Ordinary to the traveller, distorted to the witness, each real in its own frame. For us on Earth, far from such extremes, it may feel abstract, even irrelevant. After all, we're not falling into black holes, yet the principles they reveal reach into our daily lives. Without understanding relativity, GPS would fail, satellites would drift, and physics would lose coherence. And in a broader sense, black holes remind us that reality often hides its deepest truths in places that defy common sense. They whisper that time, so steady in your bedroom as you listen now, can stretch, slow, and bend until it almost disappears. The strangeness does not stop there. Physicists continue to wrestle with questions about what happens inside, about whether information can be destroyed, about how quantum mechanics and relativity reconcile in such an environment. These are puzzles for later, but they all orbit the same central mystery. What is time, really, when space-time itself collapses? For tonight, though, it is enough to linger at the horizon. Imagine standing there, just at the edge, feeling your seconds slip away differently for you than for those far away. Picture the glowing ring of light, photons bent into a circle by gravity's hand. Listen, if you like, to the faint chirp of merging giants, recorded here on Earth as space-time trembled. These images, these sounds, are not science fiction. They are real, captured by instruments and minds that stretch human perception outward, and they all say the same quiet thing: time is not what we thought. When you look back at a memory, perhaps a childhood afternoon, the light falling through a window, or the way laughter sounded in a particular room, it can feel both impossibly distant and oddly close. That day is gone, yet the memory is vivid, almost as if you could step back into it. The strangeness of this feeling touches on a profound idea in physics: the possibility that the past is not really gone, that the future is not waiting to be created, but that all of it, every moment you've ever known or will know, might coexist together in something scientists sometimes call the block universe. The block universe, or eternalism as philosophers describe it, takes Einstein's relativity to its logical conclusion. If time depends on motion and gravity, if different observers disagree on what is simultaneous, then perhaps there is no universal now at all. Instead, reality might be a four-dimensional structure in which past, present and future are all equally real, already laid out, like the length, width and height of space. Your sense of moving from one instant to the next is then not the universe flowing, but your consciousness turning its attention from page to page. Einstein himself hinted at this perspective when he wrote to a grieving friend that the separation between past, present and future is only a stubbornly persistent illusion. He did not mean that our experience of time is meaningless, but rather that, in the mathematics of relativity, there is no privileged moment called now. An event 10 years ago and an event 10 years in the future both occupy their places in the fabric of space-time. To a physicist drawing the diagram, the whole history of a particle, from its birth to its end, is already there, a line stretching across the map. To make this less abstract, imagine a book resting on a table. All the pages already exist. The first chapter is not more real than the last, even if you have not read it yet. When you read, your eyes move forward in sequence, and the story feels as though it is unfolding, but the unfolding is in you, not in the book. In the same way, eternalism suggests that time's flow is something the mind experiences, not something the universe itself is producing. There is something unsettling in this. If the future already exists, are our choices written down before we make them? Does free will have any place in such a picture? These are questions philosophers still wrestle with, and science cannot easily resolve them. But perhaps the metaphor of the book helps again. Though the pages may be printed, the meaning of the story is alive only when you read it. Your attention, your interpretation, your emotions bring the words into experience. Even if the events are fixed on paper, the life of the story happens in you. Think of how this resonates with everyday experiences. A photograph from the past still exists unchanged, though the people in it may have grown older or passed away. The light from a distant star reaches us after travelling for millions of years. When you gaze at it tonight, you are seeing not the present, but the ancient past, still shining, still real in its way. The block universe simply extends this reasoning. The past and the future too are not erased or waiting, but are as real as the light of that star, existing in the vast architecture of space-time. There is comfort here as well. If every moment is equally real, then the joys and loves you have known are not lost. They are still part of the fabric, existing forever in their place. The child you once were, the friends you once laughed with, the quiet mornings or stormy nights, they all exist, as much as this present one does. And the moments ahead, the experiences yet to come, already have their place too. We do not see them yet, just as you cannot see the last page of a book when you are still in the middle. But they are there, waiting in the structure. Of course, your body and brain still feel time as flow. You cannot live in all moments at once. Consciousness seems to move along the line, one second after another, and in that movement, we create meaning. The melody of a song is not in any single note but in their sequence. Read on a sheet of music, all the notes are present together, but it is the performance, unfolding in time, that makes the piece alive. So too with life in a block universe. Even if the structure is fixed, it is our journey through it that brings it its music. Some find this vision cold, as if life were predetermined, and others find it comforting, as if nothing is ever truly lost. But regardless of emotion, the idea flows naturally from Einstein's equations. Without a universal present, we cannot privilege this instant over another. Time becomes another dimension, one we walk through, not one that flows past us. As you rest here, listening, imagine yourself not in a river being carried forward, but in a great landscape. The hills and valleys are all there, stretching in every direction. Your path winds across it, and your view changes, but the terrain itself does not move. The block universe is like that landscape, unchanging, yet vast enough to hold every step you have taken and every step you will take. And so, all moments at once, your first breath, this quiet moment, your last word, and everything in between, all part of the same immense structure. Whether you find that idea unsettling or soothing, it offers a glimpse of reality that goes beyond intuition, reminding us that what feels most obvious may not be the deepest truth. Perhaps time's flow is a story your mind is telling, a story you live through page by page, while the universe itself rests in silence, holding every page together. The block universe suggests that every moment, past, present, and future, exists together, equally real, a grand structure spread out like a map. Yet not everyone has been willing to accept this vision. For many philosophers, and for most of us in daily life, there remains an almost irresistible conviction that only the present is real. The past has dissolved into memory, the future has not yet arrived, and what we call now is the only place where existence truly resides. This view is called presentism, and it stands in quiet tension with eternalism, the idea that all times coexist. Between these two perspectives stretches one of the most profound philosophical debates, reaching back to the earliest attempts to describe time. Long before Einstein or Newton, thinkers wrestled with this paradox. St. Augustine, writing more than 1500 years ago, offered a reflection that still resonates today. When asked what time is, he famously confessed, "If no one asks me, I know. If I try to explain it, I do not." His words capture the slipperiness of the concept. We live immersed in time, as fish live in water, but when we try to grasp it directly, it slips away. For Augustine, the puzzle was not only whether time was real, but how it could be experienced at all. The past no longer exists, the future is not yet real, and the present is so fleeting it vanishes almost before you can name it. If only the present is real, what anchors our memories and hopes? If all moments exist equally, why do we not see them all at once? Presentism feels natural because of how consciousness works. You are listening now, and this instant seems uniquely alive. The sentence I am speaking feels present, while the one just spoken is already past and the one still to come is only anticipated. This constant division between was, is, and will be shapes the rhythm of thought and action. You cannot drink yesterday's tea or sleep in tomorrow's bed. Each moment feels like the cutting edge of reality. Eternalism, by contrast, feels almost alien. It asks you to imagine that the tea you drank, the dreams you will have, and this quiet listening moment all coexist, equally solid, even if your awareness can visit only one at a time. Perhaps the best way to approach the tension is through the metaphor of music. When a piece of music is written down, every note is already there on the page, printed and fixed. That is eternalism. The entire song exists at once, from the opening measure to the final chord. But when the music is played, you hear it unfold in sequence. That is presentism. The past notes fade, the future notes have not yet sounded, and the present note is the one you inhabit. Both views are correct, each in their context. The music exists as a whole on the page, and it flows moment by moment in performance. Another everyday example is a recipe. On paper, all the steps are written, existing together. But when you actually cook, you cannot jump to the final dish without moving through the sequence. The page holds eternalism, the kitchen enacts presentism. The two are not contradictions, but perspectives. The world may be like this too, a space-time where all events are laid out, and a consciousness that moves through them as though turning a recipe into a meal. This way of thinking softens the clash. Eternalism may describe the universe as physics sees it, a structure where time is another dimension, as unchanging as space. Presentism may describe life as consciousness lives it, bound to the moving present, constructing meaning from the flow. Perhaps what we call time is simply the meeting point of these two views, the landscape of events on one side and the journeying awareness on the other. Augustine himself offered a similar reflection. He suggested that the past exists in memory, the present in direct experience, and the future in expectation. In that sense, the flow of time is stitched together inside us by the mind that remembers, attends, and anticipates. Without memory, the past would vanish entirely. Without anticipation, the future would be blank. Time, then, is not just a property of the universe, but a construction of consciousness, an art of stitching moments into a story. Consider how fragile this construction can be. In dreams, the boundaries soften. Minutes can feel like hours, or hours like moments. In deep meditation, time may seem to dissolve, leaving only a spacious present. In grief, days may feel endless. In joy, they vanish too quickly. If eternalism were the whole story, these differences would not matter. But in the life we actually live, they matter deeply, shaping how we feel and remember. The philosophy of presentism captures this lived truth. Only this moment feels alive. So which is right? The scientist points to relativity, which denies a universal present and leans toward eternalism. The human heart insists on the now, on the uniqueness of lived experience, and leans toward presentism. Perhaps the paradox is unsolvable, not because one is wrong, but because both describe different aspects of reality. The universe may be a timeless block, yet we live it as a flowing melody. As you listen tonight, perhaps think of yourself as both reader and performer. The story of your life may be written in space-time already, every page intact, but you experience it line by line, moment by moment, with memory and anticipation weaving the continuity. Both are real, the page and the reading, the whole and the flow. Augustine's paradox remains, but maybe it is not a flaw in our understanding. Maybe it is an invitation to rest in mystery, to accept that time is both there and here, both eternal and fleeting, both printed and sung. So far we have lingered in philosophy and relativity, where time bends and stretches but still remains, however oddly. Yet when we turn to quantum physics, the story becomes stranger still, because here we find equations that seem to do away with time altogether. It is one thing to say time is relative, another to say that it may not exist at the fundamental level of reality. And yet, that is exactly what some of the deepest mathematics appears to suggest. In quantum mechanics, the most familiar equations, like Schrödinger's equation, still involve time. They describe how the probability of a particle's state evolves. You can imagine it as a wave that changes shape moment by moment. But when physicists attempt to combine quantum mechanics with general relativity, aiming for a theory of quantum gravity, something unexpected happens. The variable for time, that simple t, marking the flow from past to future, quietly disappears. The Wheeler-DeWitt equation, named for John Wheeler and Bryce DeWitt, is one of the central formulations in this search, and in its mathematical form, it contains no time at all. To many, this feels almost absurd. How can an equation meant to describe the universe lack the very thing we use to mark change? But the equation seems to say reality, at its deepest level, does not evolve in time. Instead, it simply is. All possible configurations exist together in a kind of timeless state, and what we call time may emerge only when we look at parts of the whole from a particular perspective. One way to picture this is to think of a recipe without instructions for order. You might have a list of ingredients, all necessary, all present, but no sequence of steps. The dish exists in potential, not as a line of actions. Only when a cook comes along interpreting and applying the list does the meal appear in time. In the same way, the universe's deepest equation may hold everything, but only observers like us stitch it into a sequence. Time, then, is not written into the recipe. It is created in the act of cooking. Another way is to imagine a vast photograph, capturing a city in perfect detail. Within the picture are countless people frozen in action. A child reaching for a balloon, a bird mid-flight, a car at the edge of an intersection. The photo contains no motion, no before or after. Yet when you scan across it, your mind invents a narrative. The balloon rising, the bird flying, the car accelerating. The sense of time arises not from the image, but from the way you move through it. Similarly, the Wheeler-DeWitt equation describes the universe as a whole, timeless picture. Our perception of flow is a way of scanning through, not a feature of the picture itself. This is not merely abstract speculation. Experiments in quantum cosmology, though still in early stages, suggest that when we treat the universe as a whole, we cannot rely on an external clock. There is no outside time to measure against. All we have are relations between parts, how one thing changes compared to another. The tick of an atom compared to the oscillation of a photon, the swing of a pendulum compared to the decay of a particle. Without such comparisons, the idea of time loses meaning. In a universe without observers, or before observers existed, time may not have been a fundamental thread, but something woven later. Of course, to live as a human is to find this deeply unsettling. You experience your life as a sequence of befores and afters, one thought leading to the next. To be told that underneath it all there is no universal clock, only timeless relations, can feel like being told that the ground beneath your feet is not solid. But perhaps there is another way to hold it. Think of music again, but this time not as notes unfolding, but as a chord. When you strike a chord on a piano, several notes sound at once. In that single moment, harmony exists without sequence. The Wheeler-DeWitt equation might be thought of as a chord containing all possible melodies. Our lived time is one melody played out of that chord. Even Einstein struggled with the implications of such thinking. He accepted relativity's flexible time, but still believed in a coherent universe where past, present and future all had their place. Quantum mechanics, with its uncertainties and lack of a universal clock, felt less satisfying to him. Yet the mathematics remains, whispering that perhaps time is not a basic ingredient of the cosmos, but something that appears only when matter, energy and observation interact in particular ways. As you lie here, listening, it may be helpful not to wrestle with the mathematics, but to rest in the image it suggests. Imagine the universe not as a film strip rolling forward, but as a single, complete image. Imagine yourself as a traveller scanning through that image, drawing a line that feels like motion. You're the reader moving across the text, not the text itself. Time, in this view, is not an external river carrying you, but a story unfolding as you trace it. This does not diminish the value of your moments. If anything, it deepens them. To know that the flow you feel is not guaranteed, not baked into reality itself, makes each lived second precious. It is your mind, your body, your awareness that weaves the fabric of before and after. Without you, the universe may simply exist as a timeless whole. With you, it becomes a journey. If the Wheeler-DeWitt equation left us with a vision of a timeless universe, then physicist Carlo Rovelli offers a way to live within that strangeness. He does not deny that the equations of quantum gravity seem to erase the universal clock. Instead, he embraces the possibility that time is not a background at all, but something that emerges only through relationships. His idea, called relational quantum mechanics, suggests that nothing in the universe exists in isolation. Every property, every bit of information, every measure of change appears only when compared with something else. Time, in this view, is not an independent flow. It is a way of describing the relations among events, the dance of things in relation to one another. At first, this sounds abstract. But think of something as ordinary as a chessboard. A single knight placed on an empty board has no meaning. Only when other pieces are present do we understand its position. The knight is 2 squares away from the bishop, 3 from the king, threatening the rook. Its reality lies in those relationships. In the same way, Ravelli argues, the universe does not have a single master clock ticking above everything. Instead, each process, each particle, each event defines time only in relation to others. Imagine you're baking bread. The yeast expands, bubbles of air form, the dough rises. You measure the change not by consulting an absolute clock, but by watching how the dough swells compared to its earlier state, or how the aroma of baking fills the kitchen compared to how it smelled before. Your sense of time here is nothing more than noticing change in relation to what came before. Ravelli's perspective elevates this simple truth into a principle of physics. Time is not a separate stage, but the story of relationships unfolding. In everyday life, you already practice this without realizing it. When you say you will meet a friend after sunset, you are defining time not by an abstract unit, but by the relation between Earth's rotation and the fading of light. When you wait for water to boil, you're not watching seconds on a clock but noticing bubbles, steam, and change. The clock is only a tool to standardize what you already perceive relationally. Relational time also helps explain why different observers can disagree on simultaneity. If 2 events happen at distant points in space, one person moving quickly might judge them as simultaneous, while another sees one before the other. Neither is wrong, because there is no single universal time binding them. What exists are relations, how one event compares with another from a given perspective. This view softens the discomfort of timeless equations. Instead of imagining a frozen cosmos without flow, Ravelli invites us to see a dynamic web of relations, always shifting, always interacting. Time arises as a way of describing that web. It is like the pattern of a dance. The dancers move, each step defined by relation to the others, and the rhythm appears not as a separate thing, but as a description of the movement itself. There is something soothing about this. It suggests that the sense of time you carry, the feeling of moments passing, is not an illusion in the sense of being false, but a natural byproduct of how things interact. Without change, without comparison, without memory, time would indeed dissolve. But with them, time becomes a language of relationships. You're not floating in a river, you're weaving threads of relation moment by moment. Think of how this resonates with memory. When you recall yesterday, you're not retrieving a universal timestamp, but connecting today's self with a remembered state of yourself. That relation defines yesterday. When you anticipate tomorrow, you imagine a relation between now and a possible later state. In this way, memory and anticipation are relational acts, not absolute markers. Time lives in them because they connect states of being. Ravelli often describes this as humility before the universe. We want absolutes, something solid to anchor us. But reality may not grant us that. Instead, it gives us relations, patterns, interactions. And from those, time blooms like a flower. It is not less real for being relational. It is perhaps more real, because it is the very way the universe is stitched together. As you rest tonight, you can feel this in your own body. The beating of your heart is not measured against a cosmic metronome, but against your breath, your thoughts, the rhythms around you. The feeling that your heart beats faster when you are anxious or slower when you are calm is a relational truth. The rhythm shifts in comparison to the steady background of your awareness. If your awareness were gone, so would the sense of time. So in Ravelli's vision, the question is not what is time, but what are the relations that give rise to our sense of time? It is not a line drawn across the universe, but a web spun by every interaction, from the collision of galaxies to the flicker of neurons in your brain. Each relation defines its own clock, and together they form the grand mosaic we call history. This perspective may feel dizzying, but it also carries a kind of peace. If there is no master clock, no absolute tick marking our lives, then there is freedom in knowing that time is not imposed from outside but grows from within. It grows from the way we relate to others, to the world, to ourselves. Perhaps that is why moments of deep connection feel timeless. The relations are so complete that you no longer need to measure them. You're simply there, woven into the fabric of the dance. If Carlo Rovelli invites us to think of time as relations among events, Julian Barber takes an even bolder step. He suggests that time, in the way we imagine it, does not exist at all. The universe, he argues, is not a river flowing forward, nor even a landscape through which we travel. It is a vast collection of nows, each a complete, self-contained arrangement of the cosmos. These nows do not pass or vanish. They simply exist, timeless and eternal. What we call the flow of time, the feeling of one moment leading to another, is nothing more than our minds stitching together these nows into a story. In his book, The End of Time, Barber proposes that if we could see reality clearly, we would discover not a moving film, but a gallery of still photographs. At first glance, this can feel almost absurd. How can life, which feels so fluid, be nothing more than static snapshots? Yet when you reflect, you begin to notice how much of your experience already works this way. Memory, after all, is not continuous. It is a set of moments recalled and replayed. When you think of your childhood, you do not summon every instant. You recall fragments, a particular room, the smell of a holiday meal, the sound of laughter on a summer evening. Your life is not stored as a film reel, but as a photo album. In between the snapshots, your mind fills in the story, creating the impression of flow. Barber's idea elevates this familiar experience to the scale of the entire universe. Each now, he suggests, is a configuration of all things, every star, every planet, every molecule, every thought. Together these nows form what he calls Platonia, a timeless realm of possibilities. The now you inhabit right now, lying in bed, listening, perhaps with your breath slowing and your eyelids heavy, is one of countless nows. It exists alongside the now of your childhood, the now of your future, the now of galaxies colliding millions of light years away. None is more real or less real than the others. They simply are. If this is true, then time's flow is not in the universe but in us. Our minds carry traces of past nows, memories, records, scars, stories, and use them to imagine a sequence. We project ourselves forward into possible nows and call that the future. But the universe itself does not move. It simply contains. This vision can feel cold, but it can also feel oddly comforting. If all nows exist, then nothing is ever lost. The joy of a moment is always there, preserved in Platonia. The sorrow too, but also the love, the wonder, the quiet seconds you thought had vanished. To make sense of this, imagine standing in an art gallery filled with photographs. Each picture is detailed, complete, capturing a world in itself. You can walk from one to another, constructing a story, perhaps imagining that one leads to the next, but the story is yours. The photographs are not changing. They are not moving in sequence. They simply hang on the walls side by side. Barber's universe is like that gallery. The flow you feel is the act of walking through, of connecting pictures with memory and imagination. Another metaphor might be a deck of cards, each card showing a different arrangement of a puzzle. If you shuffle through them quickly, it feels like watching an animation. But the animation is in your motion, not in the cards themselves. The cards exist, unchanged. The sequence is something you impose. In the same way, Barber believes, the nows of the universe do not flow. They simply exist, timeless, waiting to be connected by minds like ours. This view challenges almost everything we take for granted. It suggests that the past is not behind us, nor the future ahead. They are alongside, equally real. It suggests that death does not erase a moment but simply means that we no longer experience future nows. The moments we live remain untouched. For some, this feels unsettling. For others, it is deeply reassuring. Barber himself often describes this perspective as freeing. If time does not flow, then the fear of its passage lessens. You're not being carried away. You're not losing moments. Each now you live is eternal in itself. It is not swallowed or erased. It simply joins the gallery. Perhaps this is why moments of beauty feel timeless. A sunset, a piece of music, a shared glance. In those instants, you sense the eternal quality of a now, complete in itself, needing no future or past to justify it. Of course, most physicists still wrestle with this idea. Many accept that time may be emergent or relational, but few are ready to declare it non-existent. Still, Barber's vision has a strange resonance with the mathematics of quantum gravity, which seems to describe the universe without reference to a flowing time. Whether or not Platonia exists as he imagines, the idea draws us into reflection. What if the deepest truth is not motion but presence? What if the universe is not a journey but a gallery? As you drift towards sleep, you can let this idea rest gently with you. Perhaps each breath, each heartbeat, is its own eternal now, complete and unbroken. Perhaps the life you're living is not slipping away but unfolding in a vast timeless collection, each moment preserved, each one real. The end of time in this sense is not a loss but a recognition. That time's flow may be our story, but the universe itself rests in stillness. If you have ever poured a cup of tea and then forgotten it on the table, you have witnessed the arrow of time in action. The steam rising, the warmth fading, the way the once comforting heat seeps into the air until the tea is cool. It all feels so ordinary. Yet behind this everyday moment lies one of the most profound principles in science, the one that gives time its direction. It is called entropy, the measure of disorder, and it is the quiet reason why we remember the past but not the future, why glasses shatter but never reassemble, why bread grows stale, why perfume disperses and never gathers itself back into the bottle. Entropy is a law of tendency, not of absolute impossibility. The second law of thermodynamics tells us that in a closed system, disorder tends to increase. There is always the possibility in theory that the molecules of steam above your tea could gather themselves back together, reheating the cup, reversing the cooling. But the odds are so astronomically against it that we can safely say it never happens. The universe in its great statistical unfolding prefers to spread out, to dissipate, to scatter. That preference is what we feel as time moving forward. Think of a tidy room. With effort, you can arrange the books neatly, place the clothes in drawers, fold the blankets. This is low entropy, a state of order. But without effort, the natural drift of life pushes toward a higher entropy. Books migrate into stacks, clothes end up on the chair, dust gathers. To restore order, you must invest energy. The universe, too, requires energy to maintain pockets of order, but the overall drift, the grand tendency, is toward disorder. That drift is what defines the arrow of time. We live in a universe where entropy increases because it began in a state of remarkable low entropy. The early universe, though dense and hot, was astonishingly uniform, a smooth spread of matter and energy. From that improbable starting point, structure has emerged: galaxies, stars, planets, and eventually life itself. But always, alongside creation, entropy has been climbing. Suns burn through fuel, heat disperses into the cosmic background, order decays. That relentless climb is the reason you can recall yesterday but not tomorrow. Memory is itself a form of order, a structure the brain builds by tracing the patterns of what has already happened. The future has no such traces yet, so we cannot remember it. Consider the bread you bake. Fresh from the oven, it is springy and fragrant, moisture evenly distributed, starches aligned. As hours pass, the bread stiffens. Moisture migrates outward, starch crystallizes. The loaf goes stale, not because it chooses to, but because entropy insists. You may warm it briefly, soften it with heat, but the trend is irreversible. Bread does not spontaneously return to its fresh-baked state. The same is true of all things. A perfume spritzed into the air spreads throughout the room, its molecules drifting outward until every corner carries a hint of scent. No one ever walks in to find the air empty, and the fragrance perfectly returned to the bottle. These small, ordinary truths are the evidence of entropy, which is to say, the evidence of time's direction. There is comfort in recognizing this arrow, because it is the rhythm of daily life. We wake, we eat, we age, we rest. Entropy guides not only cooling tea and crumbling bread, but the flow of our own bodies. We are patterns of order maintained by energy, and one day when the pattern can no longer hold, entropy will take us too. Yet even this is not something to fear. It is the same law that allows stars to shine, that allows galaxies to form, that allows life to exist in the first place. Without the climb of entropy, there would be no change, no sequence, no story. Physicists sometimes say that time's arrow is not written in the equations of motion, but in the boundary conditions, the improbable low entropy beginning of the universe. From that improbable starting point, everything else follows. The universe is not so much a clock as it is a grand diffusion, unfolding in patterns of ever-increasing complexity. And we, the witnesses, find ourselves aligned with the arrow, carried by the drift, unable to step backward against it. If you find this unsettling, think again of the tea cooling on the table. At first, you may regret having forgotten it. But when you notice it as a symbol of entropy, you might see it differently. The steam curling upward, the warmth shared with the room, the transformation of order into disorder. These are not accidents. They are the quiet poetry of the universe at work. You live inside that poetry every moment. Your memories are possible only because entropy leaves traces in the brain, physical imprints of events already unfolded. Your future remains blank because entropy has not yet written those traces. In dreams, sometimes this arrow loosens. Minutes expand or collapse. Events follow one another without clear sequence. But in waking life, entropy anchors you. It is the reason you do not confuse yesterday with tomorrow. It is the reason time, for all its mysteries, feels directional, reliable, irreversible. The second law does not need to be recited for you to live by it. You live it every time you sip tea before it cools, every time you savour bread fresh before it hardens, every time you breathe perfume as it disperses into the air. Entropy may be the quietest of all laws, but it is also the one that gives time its arrow. Without it, the universe would be a restless stillness, a static gallery of states with no order to connect them. With it, we have history, memory, anticipation, the unfolding of stories, the feeling of moving from then to now. It is not an enemy. It is the companion that makes your life intelligible, the current beneath the melody. Entropy gives us a simple, almost homely picture of time's arrow. Tea cools, bread goes stale, perfume disperses. The universe drifts from order to disorder, and we, as passengers, feel the direction of the journey. But physicists have begun to wonder if this is the whole story. Perhaps entropy is not the only thread that weaves time forward. In recent years, another possibility has emerged, one that reaches into the strange world of quantum mechanics, where particles do not behave like solid beads but like restless, uncertain clouds. There, in the quantum realm, lies the phenomenon of entanglement, and some suggest it may hold clues to why time flows at all. Quantum entanglement is one of those ideas that sounds like a riddle. Two particles, once connected, can remain linked even when separated by vast distances. Measure one, and the other's state is influenced instantly, as though distance does not matter. Einstein called it spooky action at distance, and though he doubted it, Experiments have confirmed it countless times. Entanglement is real. But what does it have to do with time? In 2013, researchers published an intriguing idea in Nature Physics. They suggested that the arrow of time might emerge not only from entropy increasing, but also from entanglement spreading. When particles interact, they do not simply move apart. They become correlated, their states bound together. As more and more particles interact, the web of entanglement grows, and with it, complexity. The universe does not just become more disordered, it becomes more entangled, more interconnected, more intricate. This growing network of correlations may itself define a direction, a sense of before and after. To picture this, think of a tidy ball of yarn. At first, the threads are wound neatly, pattern simple, easy to follow. Now imagine setting a kitten loose on it. The yarn unravels, threads looping around table legs, tangling under chairs, forming knots that no hand can easily undo. The pattern grows more complex, not less. This is not disorder in the sense of chaos, but an increase in complexity. It is the same with eggs. Crack 2 into a pan and stir, and you cannot unmix them. The final dish is not only more disordered, but also more entangled, molecules interwoven in ways they were not before. The arrow of time, some suggest, is written in that irreversible weaving. Consider also the messy room. At the start of the day, you may lay out clothes neatly, place your books in stacks. By night, without intending it, items have shifted. A sweater draped over a chair, a mug on the desk, papers spread out. The room has not only become disordered, it has become more complex. Objects are now related in new ways, the mug balancing on a notebook, the sweater half folded over the backrest. To return to the original order requires effort, because those relations cannot simply be reversed. The complexity resists undoing. In physics, entanglement plays a similar role. Once particles have interacted, their histories are intertwined. You cannot simply return them to a state of independence. The arrow of time, in this vision, is the growth of entanglement, the way the universe becomes a more intricate tapestry of relations. We live that arrow every day, though we do not notice. Every breath you take entangles your body with the atmosphere, carbon dioxide mixing with air, heat spreading into the room. Every word spoken entangles sound waves with walls, with ears, with memory. Nothing is ever completely separate again. This perspective does not replace entropy but complements it. Entropy explains why systems disperse, why order decays. Entanglement explains why correlations grow, why complexity deepens. Together they give time its asymmetry. You remember yesterday because your brain has become entangled with traces of it. You cannot remember tomorrow because no such entanglement exists yet. There is something strangely comforting in this. The universe is not merely drifting into disorder. It is also weaving connections, binding particles, patterns, and people together. Time, in this sense, is not only about loss, but about accumulation. Every moment adds threads to the web, new entanglements that cannot be undone. The arrow of time is not only a story of things falling apart, but of things becoming more interwoven. Think of conversations with friends. Each exchange adds layers to your shared history. You cannot undo the words spoken, the laughter, the silences. They remain entangled in memory. Relationships themselves are a kind of entanglement, and like quantum particles, they create direction. You know what has been said. You cannot yet know what will be said. The web grows thicker with each moment, and that thickness is the flow of time. As you rest, it may help to picture this web. Not a rigid grid, but a living tapestry, threads looping and crossing, patterns forming. The past is the part already woven, visible and fixed. The future is the unwoven threads full of potential. The present is the act of weaving, entangling one more strand into the pattern. The tapestry grows, never shrinking, never reversing. That is the arrow of time, entanglement's quiet gift. In the end, we may find that entropy and entanglement are two sides of the same story. One describes the spread of disorder, the other the growth of correlations. Together they explain why time moves in one direction, why tea cools, why eggs scramble, why lives accumulate memories. And if you ever wonder whether this story is abstract, remember the messy room, the scrambled eggs, the tangled yarn. They are as ordinary as daily life, and yet they carry within them the same profound truth as the deepest quantum equations. If entropy and entanglement explain why time has direction in our everyday world, then black holes show us what happens when time itself is stretched almost to breaking. These cosmic objects, born from the collapse of massive stars, are often described as devourers of light, but what they truly reveal is the elasticity of time. Near a black hole, the rules we take for granted falter. Seconds can dilate into centuries, and perspectives split so dramatically that two observers may describe completely different realities, both true in their own frames. Imagine for a moment that you're an astronaut drifting slowly toward the event horizon, the invisible boundary around a black hole from which nothing, not even light, can escape. To you, the journey feels ordinary, though unsettling. You check your watch and find it ticking normally. Your heartbeat feels steady, your breathing calm. Yet to a friend watching you from a safe distance, the story unfolds differently. They see your approach slow, then slow further, as though time itself is dragging its feet. The closer you come to the horizon, the more stretched your seconds become. Eventually you appear to freeze at the edge, never quite crossing, fading into a ghostly stillness. This is not a trick of perspective, but a deep truth of relativity. Time flows differently in strong gravitational fields. What feels normal to you feels infinite to the distant observer. Both stories are real, woven by the geometry of space-time, and this difference is not just theoretical. It has been measured, not at the edges of black holes, but here on Earth. Atomic clocks placed at the top and bottom of a building tick at slightly different rates, the lower one slowed by Earth's gravity. Near a black hole, this effect becomes so extreme that it divides realities. Physicists call this gravitational time dilation. The stronger the gravity, the slower time runs. At the event horizon, time for the outside observer stretches into eternity. From their point of view, nothing ever crosses the boundary. Yet from the perspective of the falling astronaut, crossing the horizon takes only moments, and nothing feels unusual. Two truths, incompatible yet equally valid, exist side by side. Time itself has become relative to position, tangled in the fabric of gravity. The awe of this realization is heightened by the fact that we have glimpsed black holes directly. In 2019, the Event Horizon Telescope produced the first image of a black hole, the glowing ring around M87 star, a supermassive giant at the centre of a distant galaxy. The image was not of the black hole itself, which remains unseen, but of the light bent and twisted around it, photons caught in orbit by gravity's pull. Looking at it was like gazing at a blurry campfire through fog, yet it carried a profound weight. It was proof that these strange objects, predicted by Einstein's equations, exist, and with them exists a place where time behaves in ways we can scarcely imagine. Even more astonishing was the detection of gravitational waves, ripples in space-time caused by the collision of black holes. In 2015, the LIGO detectors in the United States heard a faint chirp, the signature of two black holes spiraling together more than 1 billion light-years away. It was not sound in air, but the vibration of space-time itself, stretching and squeezing the detector's laser beams. Translated into audio, it became a rising note, a brief song from the cosmos. For the first time, we were not just looking at the universe, but listening to it, hearing the music of gravity itself. Within that chirp was evidence of time bending, warping, and shaking as two colossal objects merged. The idea that time can ripple like water, slow near horizons and split into different truths depending on perspective, is humbling. It reminds us that what feels so solid in our daily lives, seconds ticking on a clock, minutes slipping by in conversation, is fragile when stretched by the universe. Our experience is local, bounded by Earth's gentle gravity. But far away near the edge of black holes, time is a more fluid thing. To anchor this strangeness, think of watching a stone dropped into a pond. The ripples move outward, expanding in circles, carrying the memory of that small event far across the surface. Gravitational waves are like those ripples, but instead of water, they move through space-time itself. And like the ripples, they carry a story of stars dying, of black holes colliding, of time itself trembling. Or think of glass slowing a beam of light. To you, the light seems instant, but within the glass it has been delayed, bent, altered. Time near a black hole is like that. To the one experiencing it, the flow feels unchanged. To the distant observer, it is stretched, slowed, bent until almost unrecognizable. Both perspectives are true, each tied to the vantage point. As you drift tonight, you might picture yourself near that glowing ring, watching photons swirl around the horizon like moths around a lantern. You might hear the faint chirp of distant collisions, a lullaby carried not in sound but in gravity itself. These are not fantasies but real, measured phenomena. They whisper that time, for all its ordinary constancy in your daily life, is pliable, stretchable, and deeply tied to the fabric of space. Black holes do not just swallow matter and light, they swallow assumptions. They reveal that time is not a universal current but a local rhythm, different for each observer, stretched by gravity, shaken by collisions, rippled across the cosmos. In their darkness, we glimpse a truth both unsettling and wondrous, that time is not fixed but alive, bending with the universe itself. If black holes show us how time can nearly stop, the expanding universe shows us how time might have begun. It is tempting to think of cosmic expansion as proof of some master clock, a hand sweeping outward, counting the seconds since the beginning. But expansion is not like a clock. It is more like geometry changing, space itself stretching, galaxies riding the flow. To understand the birth of time, we have to imagine a universe so strange that the very word before may not make sense. Astronomers tell us that the universe is still expanding today. Distant galaxies drift away, the space between them widening like dots on the surface of an inflating balloon. If you draw spots on a balloon and then blow it up, each spot moves away from all the others. There is no center on the surface, only expansion everywhere at once. The same is true for the universe. From our perspective, galaxies recede, but there is no privileged center. The stretching happens throughout space itself. This expansion leads us backward in thought to a time when galaxies were closer together, stars not yet formed, matter compressed into a hot, dense state. Continue rewinding, and you reach a point where the equations describe a singularity, a moment when density and temperature were infinite. We call this the Big Bang, though the name is misleading. It was not an explosion in space, it was the expansion of space. And with that expansion came the birth of what we call time. To speak of before the Big Bang is difficult. If time itself began with expansion, then there may be no before. Asking what happened before time is like asking what lies north of the North Pole. The concept itself loses meaning. This is unsettling because our minds crave sequence. We want beginnings and endings, causes and effects. Yet the early universe may have been timeless, without clocks, without rhythms, without events to mark change. Only when structure emerged, particles condensing, forces differentiating, galaxies forming, did time take on meaning. Picture a blank page. Before words are written, it exists, but without story. Time in the early universe was like that. Space present but featureless, no sequence to follow. As matter cooled, as stars ignited, as galaxies swirled, the page filled with words and time became readable. Or think of a clock before its hands are attached. The face exists, but no ticks mark the passage. Only when the hands begin to move does the idea of time take form. Even now, the expansion of the universe is not the ticking of a clock. It is the changing of a scale. Distances increase, but there is no external metronome. The rhythm is written in the galaxies themselves, in the light stretching as it travels, red shifted like notes dropping lower in pitch. The expansion is the stage upon which time is expressed, not a clock measuring it from outside. Physicists remind us that the early universe was profoundly different from the one we know. In the first fractions of a second, particles popped into existence, collided, and vanished. The four forces of nature may have been unified, then separated as the cosmos cooled. Inflation, a brief burst of expansion faster than light, smoothed the universe into the uniform canvas we see in the cosmic microwave background, that faint afterglow still surrounding us. But in those first instants, time as we experience it may not have existed. Without stable particles, without rhythms, without entropy gradients, what does it mean to say a second passed? It is only when we step into the era of galaxies and stars, into the rise of complexity, that time becomes meaningful. Entropy begins to climb, entanglement spreads, and the arrow of time takes shape. Before that, we may be speaking of a timeless state, a potential waiting for unfolding. The universe itself had to construct the conditions that allow time to be felt. There is humility in this picture. We imagine time as eternal, flowing forever backward and forward. But science suggests it may be local, emergent, born with the cosmos and perhaps one day destined to fade. The expansion that gave it birth continues still, galaxies racing apart faster than we can follow. In billions of years, distant galaxies will vanish from view, carried beyond the horizon of what light can reach us. Future astronomers, if there are any, may look at the sky and see only their own galaxy, the rest hidden by expansion. To them, the universe will feel timeless again, not because nothing is happening, but because nothing beyond their island is visible. As you listen, imagine standing beneath the night sky, the stars scattered like dust across velvet. Each point of light is a page written long ago, photons stretched by expansion, travelling billions of years to reach your eyes. In that starlight, you see not only distance, but time itself, a record of the universe unfolding. The light from Andromeda shows us that galaxy as it was 2 million years ago. The light of more distant galaxies shows us billions of years in the past. Looking outward is looking backward. Expansion does not just shape space, it allows us to see the history of time itself. So perhaps time was born not in a moment but in a process, as the universe cooled and structure formed. Expansion did not tick seconds into existence, but created the conditions for clocks to matter. Before that, the word time may have been meaningless. Afterward, it became the thread of stories, the fabric of memory, the rhythm of life. For all the cosmic strangeness of time, its stretching near black holes, its disappearance in quantum equations, its possible birth with the universe, your most immediate experience of time is far simpler. It lives inside your chest, in the steady rhythm of your heartbeat. Long before humans built mechanical clocks, before sundials and water clocks, before pendulums and atomic oscillations, the heart was our first and most intimate timekeeper. Every beat marked a moment, every pause another. Even now, though we carry smartphones with precise atomic synchronizations, we still feel time in the pulse of our own bodies. When you're calm, resting in bed, your heartbeat slows. Seconds feel spacious, drawn out. When you're anxious or hurried, your heart races, and time seems to speed with it. This link is more than poetic. It is biological. The heart's rhythm sets the pace for blood flow, for oxygen delivery, for the body's cycles of activity and rest. In a way, your lived sense of time is braided into this pulse. It is your inner metronome, guiding not only your body but your perception of how moments pass. Scientists often speak of physical time and biological time as if they are separate. Physical time is measured by clocks, defined by the laws of relativity, adjusted for motion and gravity. It is objective, external, universal. Biological time, by contrast, is subjective, rooted in the rhythms of bodies, heartbeats, breathing, circadian cycles. Sometimes the two align, often they diverge. When you're deeply absorbed in a conversation or a piece of music, minutes on the clock vanish unnoticed, because your body's rhythms and your awareness of them shift. When you wait in a doctor's office, your heart ticks slower than your mind wants it to, and seconds feel stretched. Physical time is indifferent, but biological time is personal. This duality is not unique to humans. Every living creature carries its own rhythms. The hummingbird's heart beats more than 1,000 times a minute, its moments darting in rapid sequence. A tortoise's heart beats slowly, a handful of times each minute, its life unfolding in drawn-out calm. Which creature lives longer seconds? Physics would say their clocks measure the same, but biology suggests that lived time is different. To the hummingbird, an hour may feel like a stretch of bustling life. To the tortoise, the same span may feel unhurried, almost still. Both live fully, but the texture of their time is not the same. In spaceflight, astronauts become acutely aware of this difference. Orbiting Earth, they witness 16 sunrises and sunsets each day, external clocks of day and night dissolving into confusion. Yet their bodies still keep time, anchored in heartbeats, breathing, and circadian hormones. Physical time in orbit ticks differently than on Earth because of relativity, but biological time continues, reminding them that lived experience is not easily untethered from the body. Even in the vast silence of space, the heart insists on its rhythm. Consider how this plays out in your own life. When you climb stairs quickly, your heart pounds and the world seems to accelerate. When you lie down to rest, your pulse slows and moments expand. You can measure time in minutes or hours, but you can also measure it in beats. The 1,000 pulses that carry you through a morning, the millions that carry you through a year. Seen this way, your life is a collection of heartbeats, each one a small now stitched together into the melody of your existence. There is a quiet beauty in recognizing the heart as a clock. Unlike the indifferent tick of machines, it is alive, responsive, changing. It does not simply measure time, it embodies it. The rhythm of your heart is the rhythm of your being, the tempo of your journey. To attend to it is to feel time not as an abstraction but as presence. And yet, the heart's time is not eternal. It is finite, a limited sequence of beats. Physicians can estimate how many heartbeats different animals average across a lifetime, and remarkably, the number is often similar across species. Mice live fast and short, elephants slow and long, but both reach roughly the same total count of heartbeats. We too carry a finite number, though not written in stone. This finitude gives each beat weight. Each one is a now that will not return. Still, there is no need to treat this as ominous. Instead, it can be tender. To feel your pulse is to feel the passage of your own story. To know that time is not just something out there in the cosmos, but something happening within you, quietly, faithfully. You are both the observer of time and its instrument. Tonight, as you listen, you might rest a hand gently against your chest or your wrist. Feel the throb beneath your skin, the small rise with each beat. That rhythm is your own clock, your own arrow of time, as intimate as breath. No black hole, no distant galaxy, no quantum equation could be more personal. Time is written in your pulse, and in that rhythm, your story unfolds. If the heart is the body's oldest clock, then the brain is its most intricate timekeeper. The beating of your heart marks rhythm in pulses, but your mind gives those pulses meaning, weaving them into a sense of duration, sequence, and flow. Without the brain, time would not be experienced. It would simply be. And in the brain, time is not measured like ticks on a machine, but through a symphony of rhythms, oscillations, and patterns of activity that together create what you feel as past, present, and future. Neuroscientists often describe the brain as a network of oscillators. Neurons fire in patterns that repeat, like the rise and fall of waves. Some cycles are fast, millisecond sparks carrying signals between cells. Others are slow, governing attention, sleep, and mood. These rhythms are not synchronized by a single conductor, but by a multitude of overlapping pulses, like a choir singing in many harmonies. Together they form what could be called neural time. One of the most familiar examples is the circadian rhythm, the roughly 24-hour cycle that guides sleep and wakefulness. This rhythm is tied to light, hormones, and temperature, and it tells the body when to rest and when to rise. Disrupt it by crossing time zones or staying up too late, and you feel the disorientation we call jet lag. Your physical clock says one thing, your brain another, and until they realign, you experience time as skewed. But beyond circadian cycles, the brain also constructs time on much shorter scales. When you clap your hands, neurons in the auditory system fire in sequences that allow you to perceive the interval between claps. When you walk, your motor system anticipates the timing of each step, predicting where your foot will land. Without this internal timing, you could not play music, understand speech, or even coordinate movement. Time in the brain is not an external tick, but a woven fabric of predictions and responses. What makes this fascinating is how elastic it all is. In moments of boredom, time drags. Waiting in a doctor's office, each minute feels heavy, the second hand crawling around the clock. In moments of joy, time accelerates. A vacation afternoon seems to vanish in an instant. This elasticity is not an illusion in the sense of being false. It is how the brain measures and experiences duration. Emotional states, levels of attention, even body temperature can stretch or compress the felt passage of time. Imagine standing in line for coffee. The person in front of you fumbles for change. The barista moves slowly, and your mind, restless, magnifies each second. Then later, you sit with a friend, and a whole hour slips by unnoticed in conversation. The clock on the wall insists both intervals were precise, but your brain insists they were not. Both are true in their own domains. Physical time ticks evenly. Lived time bends and sways with experience. This elasticity is partly explained by attention. When you focus on time itself, watching a clock counting the seconds, your brain builds more markers and the interval feels longer. When your attention is absorbed in an activity, fewer markers are laid down and the span feels shorter. In this way, memory and attention shape time as much as physics does. Another layer comes from emotion. Fear can dilate moments. Survivors of accidents often report that events unfolded in slow motion, each detail painfully clear. Joy can compress them, days vanishing in what feels like hours. The brain's chemistry changes the way time is encoded. Neurotransmitters like dopamine and norepinephrine, tied to reward and arousal, alter how neurons fire and thus how durations are perceived. Time, at least in your experience, is a chemical construct. Even more curious is how the brain blends past, present, and future in every instant. Neuroscientists suggest that what we call the present is not a single point but a window, perhaps a few hundred milliseconds long, during which the brain integrates sensory inputs. Your awareness of now is already a blend of what has just happened and what your brain predicts will happen next. In this sense, the present is both memory and anticipation, stitched seamlessly into a continuous flow. Consider how this plays out in music. When you listen to a melody, you hold in mind the note that has just sounded, anticipate the one about to arrive, and live in the one you are hearing. The pleasure of music is in that weaving, the balance between memory and prediction. Without the brain's temporal integration, music would collapse into disconnected sounds. With it, music becomes alive, a river of notes carried through time. In daily life, you live this integration constantly. You catch a ball because your brain predicts its arc. You understand a sentence because you hold earlier words in memory, while anticipating what comes next. You walk across a room because you plan each step before it happens, guided by rhythm. Without these neural rhythms, life would fragment. With them, it feels smooth, continuous, a story with direction. So while physics debates whether time is fundamental or emergent, the brain lives untroubled in its own construction of time. It bends and stretches seconds, slows them in fear, accelerates them in joy, stitches them into the present with memory and prediction. Your experience of time is not simply given, it is made moment by moment by your own neural orchestra. And perhaps that is the lesson for tonight. Physical time may stretch near black holes and vanish in equations, but lived time, the time you feel, is woven by heartbeats and brain rhythms, by attention and memory, by joy and sorrow. It is not absolute, but it is yours, and it is the only time you truly live. If waking life is measured by the heart and shaped by the brain's rhythms, then sleep is where those anchors loosen, and time begins to blur. In dreams, the rules you rely on during the day give way to something stranger. Minutes can stretch into hours, or whole stories can unfold in the space of a few seconds. You can wake from a dream convinced you have lived through a long journey, only to discover that mere moments have passed. It is here, in the drifting space of sleep, that we glimpse most clearly how much of time is something our minds construct. During sleep, the brain does not stop working. It shifts gears, cycling through stages, some deep and slow, others rapid and vivid. The phase called REM, rapid eye movement sleep, is the one most closely tied to dreaming. In REM, brain activity resembles waking life, though unmoored from the usual anchors of external reality. Neurons fire in rich patterns, weaving narratives, characters, and images. Yet these stories unfold without the steadying rhythm of clocks, without the grounding of consistent duration. Time in dreams is elastic because the brain is not bound by the same rules of attention and memory it follows when awake. Consider how this feels. You might dream of walking through a city, talking with someone, then travelling by train or plane, all in what seems like an afternoon. But in the waking world, the dream might last only minutes. The brain does not encode dream events with the same time stamping it uses in waking perception. Instead, it layers impressions, stitching them into a narrative that feels coherent, even as it bends duration beyond recognition. This is not just fanciful. Studies have shown that when sleepers are given cues, such as counting tasks, they can perform them in dreams at roughly the same speed as when awake. Yet the narrative content of the dream can stretch around those tasks, expanding a few counted seconds into a sprawling storyline. It is as though the mind uses time as clay, shaping it to fit the story rather than fitting the story to the clock. Dreams reveal something profound, that our sense of time is inseparable from storytelling. When you dream, you're both author and audience, creating and living the tale simultaneously. The plot can jump, compress, rewind, and still feel continuous. Waking life, of course, demands stricter rules. But perhaps even there, what you experience as time is a kind of dream, a narrative stitched by the brain to make sense of change. Dreams also show us how creativity often flourishes when time's grip is loose. Paul McCartney once described how the melody of yesterday came to him in a dream, fully formed. Dmitry Mendeleev reportedly saw the periodic table in a dream, its pattern revealed as though whispered by sleep. These moments remind us that when the mind slips free of the rigid ticking of clocks, it can wander into connections that waking logic might overlook. Timelessness can be fertile ground for discovery. Think of your own dreams, the ones that linger when you wake. Perhaps you are back in a childhood home, speaking with people long gone, or standing in a place you have never visited but felt you knew. In those dreams, time bends freely. The child you once were and the adult you are now can meet in the same room. The long past and the imagined future coexist without contradiction. Waking, you might dismiss it as fantasy, but perhaps it is also a lesson that your mind is capable of living outside linear time, even if only briefly. From a scientific perspective, this tells us something important. The sense of time you carry during the day is not inevitable. It is constructed, flexible, and dependent on neural processes that can shift. Sleep experiments show that brain areas involved in sequencing and memory quiet down in dreams, while areas tied to imagery and emotion light up. The result is a perception of time that is vivid yet unbound. In that looseness, the ordinary arrow of time falters, and you glimpse something closer to the timeless states physicists imagine in their equations. As you lie here, perhaps already drifting towards sleep, notice how your awareness of seconds begins to soften. At first, you might feel the rhythm of your breath or the faint pulse of your heart, but as drowsiness deepens, even those rhythms blur. Minutes can pass unnoticed. You surrender to the dream world where time's rules dissolve and stories unfold in their own strange cadence. It is not an absence of time, but a reshaping of it, a reminder that the flow you take for granted is fragile, dependent on attention, memory, and rhythm. Dreams are the nightly theatre in which your brain rehearses timelessness. They are proof that your mind can live without the strict scaffolding of the clock. In that sense, they are not separate from physics, but resonant with it. Just as quantum equations suggest a universe without a fundamental time, your brain demonstrates that life can still feel rich and full, even when time loosens its grip. Perhaps that is why dreaming has always fascinated humans, inspiring myths of other worlds, journeys to underworlds or heavens, meetings with ancestors or gods. Dreams show us, in intimate ways, that existence does not need a single arrow to be meaningful. And so, when you next awaken from a dream that seemed long and vivid, you can remember that you have already experienced timelessness. You've lived outside the ordinary arrow, if only for a moment. The physics of black holes and quantum entanglement may be distant and abstract, but the experience of time bending is nightly and personal. Sleep gives it to you freely, wrapping you in stories that ignore the clock. If there is one place where time reveals its strangeness most vividly for humans, it is in orbit above Earth. Astronauts aboard the International Space Station live in a world where the rhythms that anchor our daily lives are dissolved, replaced by a ceaseless cycle that bears little resemblance to what we know on the ground. Their clocks tick as ours do, but their experience of time is dislocated, fractured, and sometimes eerily timeless. The ISS circles our planet once every 90 minutes. In a single day, astronauts witness 16 sunrises and 16 sunsets. Imagine waking to dawn, watching the sky blaze with light, only to see the sun slip below the horizon less than an hour later, and then rise again before you have even finished the day's first tasks. The distinction between morning and evening, between workday and night, blurs until it almost disappears. On Earth, the sun is one of our oldest clocks, guiding agriculture, prayer, meals, and sleep. In orbit, the sun becomes almost too abundant, repeating so quickly that it ceases to be a reliable anchor. To cope, mission planners enforce artificial cycles of 16 waking hours and 8 hours for sleep. Lights are dimmed, schedules are fixed, and astronauts wear eye masks to block the frequent sunrises. Yet even with these measures, many report a sense of timelessness, as if life aboard the station is unmoored. The external cues that tell the body when to rest and when to rise are absent or distorted. The brain, accustomed to days and nights, struggles to adjust. Microgravity adds another layer of strangeness. On Earth, gravity itself is a kind of anchor. It orients your body, grounds your sense of up and down, gives weight to objects. In space, weight is gone. Astronauts float, and so does everything else. Everyday gestures, placing a pen on a desk, setting down a cup, even letting go of a tool, must be relearned, because objects no longer stay where you leave them. One astronaut, returning to Earth after months in orbit, admitted that he let go of a glass at his kitchen table, forgetting it would fall. His body had been so trained to expect objects to hover that the habit of gravity had faded. Time, too, is trained by habit, and in space the habits unravel. There is a quiet poetry in this dislocation. Imagine drinking coffee from a pouch while the Earth spins beneath you, continents sliding past in silence. You look down at cities, oceans, deserts, but you're detached from their rhythms. No footsteps echoing with the clock of gravity. No evening shadows stretching across sidewalks. No bedtime marked by stars slowly wheeling overhead. Instead, there is only the constant turning, the rapid alternation of light and dark, and the hum of machines keeping you alive. Some astronauts describe the effect as a kind of suspension, a place where time feels thinner, stretched out. Tasks still follow one another, experiments, maintenance, exercise, but the backdrop of familiar cues is gone. In their absence, minutes and hours lose texture. Sleep can feel elusive, not because the body is unwilling, but because the mind, deprived of anchors, drifts. The sense of now becomes more fragile when the sun no longer measures it. And yet astronauts also speak of moments when time feels expanded into wonder. Looking out of the station's cupola windows, they see Earth framed against the darkness of space. Storm systems swirl, lightning flashes, mountains rise and fall in miniature as the station races overhead. Each glimpse lasts only minutes before the view changes, yet the impression lingers, timeless. The image of Earth floating in blackness, fragile and radiant, is etched into memory beyond the usual scale of seconds or hours. To understand their experience, compare it with jet lag here on Earth. When you fly across several time zones, your body insists it is night while the clock says it is day. You feel caught between two definitions of time, unmoored, disoriented. On the ISS, that sensation never fully resolves. It is not just a matter of adjusting, it is life itself. The astronauts live with permanent dislocation, moving so fast that the planet's familiar rhythms blur into something alien. For us, time is marked by daily anchors, meals, work, sunlight, shadows. Without them, we discover how much of our sense of time is constructed, not absolute. Astronauts embody this truth. They prove that time is not only relative in Einstein's sense, bent by speed and gravity, but relative in the human sense, bent by habit, by cues, by what the body expects. It is a reminder that physics and psychology meet in space. The equations predict that clocks on the ISS tick at different rates than those on Earth, slightly faster because of weaker gravity, slightly slower because of higher speed. But the astronauts are not only living those relativistic truths, they are living the human ones. They discover that time is not simply measured, it is felt, and that feeling can dissolve when the usual anchors vanish. As you lie here tonight, you can imagine yourself aboard that station, circling the Earth every 90 minutes. Picture the repeated sunrises and sunsets, the endless cycle of light and dark. Imagine objects floating, drifting beside you, refusing to stay put. Imagine the silence, the sense of suspension. Perhaps you would lose track of hours, days, even weeks. Perhaps you would begin to feel that time itself had grown lighter, thinner. like gravity let go of it too. And in that image lies a truth worth carrying. Our sense of time is fragile, shaped by Earth, by gravity, by sunrise and sunset. Remove those anchors and time becomes something else, less linear, less certain, more dreamlike. Astronauts live this truth daily, teaching us that time is not an absolute we inherit from the universe, but an experience we build together with our environment. If astronauts in orbit show us how time can dissolve when its usual anchors are removed, mindfulness and meditation show us how time can soften, even here on Earth, without leaving the ground. You do not need to circle the planet 16 times a day to feel how fragile the sense of time can be. All you need is to sit quietly, close your eyes, and notice the rhythm of your breath. Already the minutes begin to feel different, slower, more expansive. Sometimes they disappear altogether, leaving only presence, a kind of timeless awareness that resembles what physicists describe when they imagine a universe without clocks. Researchers studying meditation often report that practitioners lose track of duration. A session that lasts half an hour may feel like only a few minutes, or like an endless stretch without beginning or end. The sense of before and after fades, and what remains is simply now. This is not a mystical exaggeration, but a measurable shift in brain activity. Areas involved in self-monitoring and sequencing quiet down, while networks linked to attention and sensory awareness light up. The result is an experience of time reshaped, not as a line moving forward, but as a spacious field that does not need to move at all. You may have felt glimpses of this even without formal meditation. Think of drinking a cup of tea slowly, noticing the warmth in your hands, the aroma curling upward, the taste unfolding on your tongue. For those few moments, you are not thinking about tomorrow's plans or yesterday's mistakes. You are simply present, and in that presence the clock recedes. The same happens when you listen to rain against a window. The steady rhythm of droplets seems to fill the moment completely, so that you do not feel time moving, but rather resting, suspended in the sound. Mindfulness is often described as navigation without a clock. Instead of moving forward, you sink into what is already here. In physics, some propose that time itself may be emergent, stitched together by change and relations rather than existing as a fundamental backdrop. Mindfulness enacts this at the human scale. When you let go of the clock, what remains is the raw texture of experience, the feel of the breath, the sound of rain, the taste of tea. Time is not flowing, it is unfolding only as you notice it. This does not mean that clocks are useless. They are essential for appointments, journeys, and daily life. But clocks do not measure your experience of time. They only mark change in a mechanical system. Your awareness gives those changes meaning. When you slow that awareness, the minutes shift. You might sit for 10 minutes and feel it as an eternity of calm, or lose yourself for an hour in contemplation and feel it as a single breath. Studies have shown that mindfulness training can alter how the brain perceives duration. People who meditate regularly often report that stressful moments feel less oppressive because they no longer magnify each second with restless attention. A long wait feels shorter when you're not counting it. In this way, mindfulness reshapes not only subjective time, but emotional time. It turns the arrow of time from something rushing forward into something you inhabit gently, without resistance. Think of walking in nature, without destination. If you're in a hurry, each bend in the path feels like a delay. You notice the minutes slipping, but if you are walking mindfully, you do not measure. You notice the crunch of leaves, the call of birds, the play of light on branches. The path itself is the point, not the time it takes. Suddenly, whether you have walked for 10 minutes or an hour matters less. Presence has replaced measurement. In a way, mindfulness brings philosophy into daily life. If physicists debate whether time is fundamental or emergent, mindfulness suggests that for us, time is as real as the attention we give it. Stop attending, and it softens. redirect attention, and it stretches or contracts. Presence is not about denying time, but about inhabiting it differently. Not as a river that sweeps you along, but as a pool of still water where you can rest. This perspective can reshape urgency. Many of us live with constant clocks, deadlines, alarms, calendars, reminders. They create pressure, the sense that time is scarce, that it must be managed, guarded, maximized. Mindfulness offers another truth. When you're present, time is not scarce, it is abundant. Each moment is complete in itself. The tick of the second hand does not steal from you but invites you deeper into now. Tonight, as you listen, you might experiment with this. Notice your breath, the slow rise and fall. Notice the sounds around you, the hum of a fan, the distant noise of a street, the subtle silence between. Let the clock recede, let the minutes lose their urgency. In this space, you're not rushing toward the future or clinging to the past. You're simply present, and in that presence, time loses its sharp edges. Perhaps this is the lesson mindfulness shares with physics. If time is not fundamental but emergent, then living does not require us to cling to it. We can let go, breathe, and attend to the richness of now. Whether or not the universe itself is timeless, your own experience can be. All it takes is presence, attention, and the willingness to put down the clock, if only for a little while. By now, we have wandered through many faces of time, elastic in relativity, absent in quantum equations, directional in entropy, dreamlike in sleep, and fragile in the lives of astronauts floating above Earth. And after all of that, you may begin to wonder, if time is not fundamental, if it is emergent or relational, then what does that mean for how we live? If time is not a river sweeping us forward, then what are we doing in it? The answer may be that life is not adrift at all, but a walk across a landscape, one that does not move but simply exists, waiting for us to choose our path. The metaphor of time as a river is ancient and familiar. It gives us language for change. We speak of flowing, of currents, of being carried along. But if physics is right, if there is no universal flow, then perhaps we are not passengers but travellers on solid ground. The universe may be a landscape of events, already spread out like valleys and mountains waiting to be walked. Our lives then are not drifts but journeys, shaped not by the pull of the river but by the choices we make at each fork in the path. Think of standing in a meadow with no set destination. You can walk toward the trees, toward the hills, or simply linger in place. The meadow does not flow away from you. It is you who moves within it. This is how life might be if time is emergent, not something slipping through your fingers, but something you traverse. The urgency of clocks and deadlines can soften in this vision. There is still change, still birth and death, still beginnings and endings, but the sense of being rushed by a river is replaced with the recognition that meaning lies in where you step, not in how quickly you move. If you live by the river metaphor, urgency feels inevitable. The current is always carrying you forward, whether you're ready or not. But if you live by the landscape metaphor, urgency is reframed. There is still responsibility. You cannot stand still forever, but the panic of being swept away diminishes. Choices matter, not because time is running out, but because the landscape is vast, and your steps shape the path you take. This perspective reshapes patience as well. In a river, waiting feels like a loss. The water moves whether you do or not. But in a landscape, waiting can be part of the journey. Sitting under a tree watching clouds pass is not wasted. It is a way of inhabiting the terrain. When time is a landscape, patience becomes less about enduring and more about attending, noticing the texture of where you are rather than straining toward where you might be. Consider how this plays out in daily life. Imagine a deadline approaching at work. The clock insists time is scarce, minutes draining away. anxiety rises because you picture yourself in a river that will sweep the opportunity past you if you do not finish in time. Now imagine reframing it as a landscape. The deadline is still there, but instead of being swept, you are walking. You can choose your steps, pace yourself, notice what is around you as you go. The landscape does not vanish, it waits. The pressure eases and clarity emerges. In relationships too, this metaphor changes things. We often speak of time lost with loved ones, of moments slipping away. But if moments are places rather than flowing water, then nothing is truly lost. The afternoon you spent laughing with a friend still exists in the landscape of your life, as real as the step you take today. You cannot return to it, but it has not been erased. It is part of the terrain, always there, even if unseen from your current vantage point. This way of seeing is not meant to erase grief or diminish urgency. It is meant to soften them. If time is emergent, then you're not trapped in a rushing current but walking freely, choosing where to give your attention. Urgency becomes choice. Patience becomes presence. Meaning arises not from racing against the clock, but from noticing the ground beneath your feet. Philosophers sometimes call this navigating a timeless landscape. Physics hints that time is not an ultimate feature of reality, but something that emerges from change, from entropy, from relations. Mindfulness reminds us that presence does not require measurement. Together they suggest that life is not about fighting the current, but about walking with awareness, choosing how to inhabit each step. As you rest tonight, you might picture yourself in such a landscape. Perhaps it is a field stretching endlessly, or a coastline bending into the distance, or a quiet forest with paths winding among the trees. Each step you take is a moment. The path behind you is memory. The path ahead is anticipation. The landscape itself is timeless, already containing every possibility. Your life is the journey through it, not the current carrying you away. If this is true, then urgency and patience are not opposites but companions. Urgency can guide you when choice matters, when the path forks and you must decide. Patience can guide you when choice is not yet needed, when the best step is simply to stand still and notice. Both belong in the landscape, both are part of how you navigate, and meaning, the kind that lingers, arises not from rushing nor from waiting, but from presence, the way you actually attend to the ground beneath you. After wandering through relativity, entropy, quantum equations, black holes, and the vast expansion of the cosmos, we arrive at a quieter question, one that feels intimate, almost unsettling. If physics suggests that time is not fundamental, if it is emergent or even absent at the deepest levels of reality, then perhaps what we call time lives only in the mind. Perhaps it is not something the universe possesses, but something we create, the story our awareness tells to make sense of change. This is not a new thought. Philosophers for centuries have wondered whether time is something out there or something in here. Augustine confessed that when no one asks him, he knows what time is, but when asked to explain, he no longer knows. Modern physicists echo the same puzzle. Carlo Rovelli has suggested that time is not a feature of the world, but of our perception, stitched together from memory and anticipation. In this sense, time may be less like a river flowing outside us, and more like a narrative our minds compose, moment by moment. Consider how memory works. You can close your eyes and recall yesterday, perhaps the taste of your breakfast, or the sound of a conversation. That memory is not the past itself, but a pattern of neurons firing in your brain, recreating a fragment of experience. Your sense of yesterday is a construction, a story pieced together from traces. Without memory, the past would not exist for you. It would vanish as soon as it happened. Time's reality in your life depends on your ability to remember. The same is true of the future. When you plan tomorrow, when you anticipate a meeting or imagine a holiday, you're not touching the future itself. You're projecting from the present, creating a mental image of what might come. That projection gives the future weight, but it too is a story. The actual future remains unknown. In this way, your mind is always holding three threads at once: memory of the past, experience of the present, anticipation of the future, and weaving them into a continuous sense of flow. Without that weaving, time as you know it would collapse. This becomes especially clear in moments when the weaving falters. Patients with memory disorders, for example, often live in a perpetual present, unable to recall yesterday or imagine tomorrow. For them, time does not flow in the same way it does for others. The arrow weakens because the narrative thread has been cut. On the other hand, in dreams, where memory and anticipation operate differently, time can stretch or compress wildly, reminding us again that the mind itself is the loom. To anchor this thought, imagine listening to a story told aloud. The meaning comes not only from each word, but from how you remember the words that came before and anticipate the ones still to come. If you could not remember, if each word vanished as soon as you heard it, the story would dissolve into noise. If you could not anticipate, the story would lose momentum. The flow you experience is not in the words themselves, but in the way your mind stitches them together. So it may be with time. The universe offers change. The mind offers continuity. Together they create the experience of time. This does not mean that time is unreal. It means that what you feel as time may be more like a lens than a substance, a way of interpreting the shifting relations of the world. Physics may describe a block universe, or a set of timeless nows, or a network of entanglements, but you experience life as a story because your brain insists on telling it. Without that story, you would have no self. Who you are is partly defined by how you remember your past and imagine your future. Time is not only a measure of change, it is the narrative thread of identity. This realization can be unsettling. If time is only in the mind, then what happens when the mind rests, when memory fades, when attention drifts? Does time cease? Perhaps in a sense it does, at least for you. That is why moments of deep meditation, where attention collapses into pure presence, feel timeless. The narrative stops weaving, and what remains is simply awareness without sequence. That state resembles the timeless universe described by physicists. No before, no after, only being. And yet, even if time is a story, it is a necessary one. We could not live without it. Memory and anticipation allow us to learn, to plan, to connect cause and effect. They allow us to love, because love depends on shared history and imagined futures. They allow us to mourn, because mourning depends on remembering what has been lost. If time is only in the mind, it is nonetheless the fabric of human life. Illusion or not, it holds meaning. Think of it like a rainbow. Physics tells us a rainbow is not a thing hanging in the sky, but a pattern of light refracted through raindrops, appearing differently to each observer. Yet the rainbow is real in experience, beautiful, meaningful. Time may be the same, not a thing the universe holds, but a pattern emerging from how we perceive change. It may not exist outside us, but within us it is as real as any rainbow. So perhaps asking whether time is really out there is the wrong question. Perhaps the better question is, what does time mean for us? And the answer is simple. Time is the way we tell our story. It is the way we connect the child we once were with the person we are now, and the person we hope to become. It is the way we find coherence in change, the way we build identity in a world that never stops shifting. As you listen tonight, you might let that thought settle gently. Time may not be fundamental, but it is what allows you to live as yourself. Whether it is illusion, perception, or narrative, it is the thread that weaves your days together. And even if the universe itself does not need time, you do. And that is enough. And now we have reached the quiet end of this long wandering. We began by asking what time is and whether the universe could exist without it. Along the way, we explored relativity's elastic clocks, black holes where moments stretch to infinity, quantum equations that erase the very symbol of T, and dreams that weave entire stories in the span of seconds. We travelled outward into galaxies and inward into heartbeats, touched the vastness of cosmic expansion and the intimacy of mindfulness, and saw that time is both everywhere and nowhere, both scientific puzzle and human necessity. But as we close, we do not need a summary of arguments or a conclusion stamped with certainty. What we need is a feeling, something soft to carry with us into rest. Time, as we've seen, slips. It stretches and contracts. It folds itself into places we cannot quite follow. It shows us one face in the equations of physics, another in the rhythms of our bodies, another in the stories of our minds. Perhaps it is real. Perhaps it is emergent. Perhaps it is only the music of perception. But whatever its nature, it has carried us through this evening, through these words, through this gentle exploration together. And maybe that is all we ever need. Not to solve time, but to live in it. Think of a clock ticking in another room. You hear it faintly at first, each second marked, one after another. Then, as you settle into quiet, the sound fades. Your attention shifts, your breathing slows, and the tick recedes until it is no longer part of your awareness. The clock still ticks, but for you, it has disappeared. So it may be with time itself. It continues, or perhaps it does not. But either way, you can let it fade from your awareness and simply rest in stillness. Or picture yourself walking at dusk, the light fading, the horizon softening. You're not counting minutes. You're not measuring steps. You're simply there, in the cool air, the colours of the evening sky unfolding without rush. That too is a way of living outside the clock. It is not that time has vanished, but that it has softened, become less like a river and more like a quiet background hum. Whether time is fundamental or illusion, you carry within you a need for rhythm. The heartbeat, the breath, the cycles of sleep and wake, all remind us that life is shaped not by endless stillness, but by gentle patterns. Even in timelessness, we seek cadence. Even in silence, we hear a beat. This is not a contradiction. It is a balance. Time may not be written into the foundation of the universe, but rhythm gives coherence to the human story. As you drift tonight, you might let go of the urge to solve the mystery. You do not need to decide whether time is an illusion or a dimension, whether it began with the Big Bang or exists only in the mind. You can simply notice that here you are, alive in this moment, listening, breathing. You can feel the rhythm of your pulse, the rise and fall of your chest, the quiet drift of thought as it begins to soften. This is your time, and it is enough. And so we close, not with a final answer, but with an invitation. Wherever you are, in a city lit by neon, in a small town fading into night, in a quiet countryside where crickets sing, you are part of the same mystery. The seconds you feel, the hours you measure, the years you remember, are threads of a story larger than any clock can hold. Whether that story is fundamental or emergent, real or imagined, it is yours, and it can be lived with presence, with patience, with wonder. Thank you for joining me on this journey. It has been a privilege to wander with you, to explore questions that have no easy answers, but that still open doors to awe. If you have stayed awake, I hope the thoughts have given you gentle company. If you have drifted to sleep, may your dreams be soft and timeless. And if you find yourself somewhere in between, eyes heavy, thoughts loose, awareness floating, then you are exactly where you need to be. Time will carry us onward, or perhaps it will not. Either way, here in this stillness we can rest,